Have you ever stopped to think about how your favorite game saves your high score? Or how a Notes app on your phone remembers what you typed yesterday, even after a restart? Well, it's not magic. It's actually a really fundamental and kind of elegant process called file handling. Today, we're going to pull back the curtain and see exactly how programs remember things. So let's start with the big question, right? This is the central mystery. You close your laptop, you turn off your phone, but everything's still there when you come back. Your documents, your game progress, it's all waiting for you. How on earth does a machine hold on to information when the power is completely gone? To really get this, we're going to use a simple analogy that I think makes it all click. Let's think about a computer's memory just like we think about our own brains, with its fleeting thoughts and its permanent written down notes. Okay, so imagine you're doing some math in your head. You're juggling all those numbers, right? It's all happening in your short-term memory. It's super fast, it's active, but if someone walks in and distracts you, poof, it can all just disappear. Well, a running program is pretty much the same. It uses the computer's RAM, that's random access memory, as its short-term workspace. It's incredibly fast, but it's also what we call volatile. The second that program closes or the computer shuts down, everything in that workspace is gone, wiped clean. So what do you do when you have an idea you absolutely cannot forget? You write it down, right? You make a note, you create a permanent record. A program does the exact same thing to create a long-term memory. It writes that information down into a file, saving it on the computer's hard drive for later. So a program needs to write things down. Simple enough. But how does it actually get its hands on that digital pen and paper? Well, in the world of Python, the whole process kicks off with one simple, super powerful command. And there it is, the open command. You can think of this as the program basically telling the computer's operating system, hey, I need to work with a file, can you get it ready for me? It's the digital version of picking up a pen and grabbing a fresh sheet of paper. But, just grabbing the pen isn't quite enough. The program has to be really specific about what it's planning to do. Is it about to start a brand new, totally blank page? Or is it just adding a new thought to the bottom of a note that's already there? This is where something called the file's access mode comes in. And you can see just how clear these intentions are. Using W for write is like getting a totally fresh sheet of paper. Anything that was there before gets wiped out. Using A for append is like finding the last sentence he wrote and just adding a new one right after it. And X for exclusive creation, that's a really neat safety check. It basically says, hey, create this new file for me, but only if one with the same name doesn't already exist. Pretty smart. All right, so the program has opened the file and it's declared its intention. Now it's time for the fun part, actually writing something down. And this slide just lays out the difference perfectly. On the left, write mode always starts from scratch. This is great for something like a settings file where you only care about the most recent configuration. But on the right, append mode preserves what's already there. This is perfect for things like log files, where every new event just gets tacked onto the end of a growing list. And the command itself? It's as simple as it looks. Once that file is open, you just use the .write method, and you give it the piece of text you want to save. That's it. The program has now successfully made its permanent note. But of course, saving information is only half the battle, isn't it? The real magic happens when the program can come back later, open that notebook, and read its own notes back to itself. And Python gives us a few different tools for this. File.read is like looking at the entire page all at once. It just grabs all the text and gives it to you in one big block. File.readLine is a bit more careful. It reads just one line and then stops, which is perfect if you need to process a file step by step. And File.readLines is super useful. It reads the whole file, but it neatly organizes each line as its own item in a list. Super handy. So yeah, choosing the right method is really key. And that's really it. This simple cycle, opening a file, writing to it, closing it, and then later opening it to read, that is the fundamental process behind so much of the digital world we use every single day. Every saved game, every document, every browser bookmark. It all relies on this same elegant logic. Now, the methods we've looked at so far, they absolutely work. But they do carry a little bit of a hidden risk, a potential problem that can cause some major headaches. So let's look at the professional's technique for getting around it. See, in the old way of doing things, after you were done writing or reading, you had to explicitly tell the program, okay, I'm done, please close the file now, using the file.close command. It's kind of like having to consciously remember to put the cap back on your pen every single time you use it. And here's the danger.
What if your program hits an error and crashes after you've opened the file, but before you've had a chance to close it? Well, that file gets left hanging open. The cap is off the pen, and the ink can spill, so to speak. This can lead to corrupted data, and that is never, ever a good thing.
Thankfully, Python gives us a much cleaner, much safer, and just more elegant solution to this whole problem. It's called the with statement. The with statement is basically a self-managing workspace. You tell it which file to open, and then you do all your work inside its special block of code. The moment your program is done and leaves that block, and this is the key part, even if an error forces it to leave, the with statement guarantees that the file will be closed properly. No leaks, no corruption, just safe, reliable code. And the difference is it's immediately obvious on this slide, isn't it? On the left, the old way needs 3 steps. You open, you do your work, and then you have that easily forgotten close step. But on the right, the modern with statement is shorter, it's easier to read, and it has that crucial safety net built right in. It's just better. It's cleaner code, plain and simple. So when you think about it, one of the most fundamental things our software can do, the ability to remember, it all boils down to this simple, logical process of writing and reading files. And when you see how elegantly it's all designed, it really makes you wonder, doesn't it? What other incredibly powerful yet simple solutions are hiding right there in plain sight, just waiting for us to understand them?